Good morning, y'all. These are the examples from the notes for 7.3, where we learned how to go from point slope form into slope-intercept form. If you need a little bit of a review about point slope form, you can check out the notes from 7.1 or 7.2. I believe I'm given the right number. And I just double checked, and yes, I was giving the right number. Excellent. So we are going to be working on moving this equation around so that we can get it into slope-intercept form. If you remember, slope-intercept form is something we learned about last unit. If you want more information on that, you can check out Unit 6. And just as a reminder, though, the formula is y equals mx plus b. So we're trying to get it into a formula that starts with y equals. So essentially, this is just like we did last semester where we picked a variable and we're solving for it. So we are going to follow all of our rules from last go around. Yay! We're going to distribute. We're going to combine like terms. I know the little Pear Deck thing is in the way, but we're going to distribute, combine like terms if we can, add or subtract across the equal sign, and then multiply or divide across the equal sign if we can. So first up, we look at our equation, and I'm going to go ahead and rewrite it just so I have it in my own handwriting so I can see it, my own, be what it may, beautiful handwriting. So I do know when I'm following these steps in that diagram down below that I want to make sure I go in order, and please make sure that that you're following along with the top half of it. You're only staying on one side of the equal sign, and then for the bottom half you are crossing the equal sign, and that can get a little tricky, but if you practice you can get a little used to it. So the first thing that we notice that we're looking for is we look for distribution, and I can distribute this 3 into that x plus 5. Remember, whenever we see something outside of parentheses like this, it means that we're distributing. And whenever I see it mushed up like that, that is multiplication. So distribution, there's no distribution I can do on this side. So I'm going to go ahead and write my y minus 2 again, because that side of the equal sign stays the same, y minus 2. But then when I distributed, I found 3 times x is actually 3x. Remember, when we have a number and a letter mushed together, that is multiplying. 3x plus, I know that 3 times 5 is 15. You can use a calculator or you can use our Desmos. I would prefer you to be starting to use Desmos because that is what you're going to have available to you. So we have done our distribution. Now let's check out combining like terms. Are there any like terms? And remember, we can't cross the equal sign. So I can't combine y minus 2. There's no way for me to combine that. So those aren't like terms, can't combine there. I also look at 3x plus 15. I can't combine anything there. There are no like terms. So can't do that step. Moving along. Now I need to look at adding or subtracting across the equal sign. And remember, my whole goal here is to try to get that y by itself. I'm trying to solve for y. I'm trying to isolate or quarantine, if you're more familiar with that word, the y. So I look for what else is happening on the same side of the equation, of the equal sign, as the y, and I see that there's also a negative 2. I need that negative 2 out of there. I need it to go to the other side of the equation. So I can use inverse operations. Remember, that means the opposite operation. So I know that the opposite of minus 2 is plus 2. Plus 2. And if I do something to one side of the equal sign, I have to do it to the other. And I'm going to line mine up with the 15 because 2 and 15 are like terms. I can add those. I can't add the 2 to the 3x though. Okay. So I do have, now I'm going to have y equals 3x and then I know when I use my calculator or Desmos, I know that 15 plus 2 is 17. Okay, so now I have actually hit my, I have gotten my variable isolated, so I don't really need to multiply or divide anything. I can go ahead and call this one done because I have solved. I have gotten into that y equals mx plus b form where it says y equals my m. I definitely have a value being multiplied by my x so that my m value is going to be 3. My slope for this is going to be 3, and my b value, my y-intercept, is going to be 17. So I'll give you just a second to go ahead and pause and work on your own or screenshot if you would like. Okay, we're going to go ahead and go on to the next one. Example 2. Rewrite this equation in slope-intercept form. We have y minus 1 equals 1/4 times x minus 12. So I'm going to go ahead like I did before and rewrite it in my own handwriting. Remember, guys, that when we are doing these, we are trying to move from that point slope to that slope intercept, which means we're trying to just get the y by itself. And the reason we do that is that it's a lot easier, I think, and I think you guys have seen, it's a lot easier to look at the slope intercept version of a graph and graph it than it is to look at the point slope form. That can get really tricky and really confusing. There's a lot more numbers and signs in there and a lot more room for error. So I have y minus 1 equals 1/4 times x minus 12. A lot of people look at this and they're like, well, I need to get the y by itself. So I'm just going to add 1 because I can just get rid of that 1 and then I'm done. But that breaks our rules. That is not what we're going to do here, because we didn't follow our pattern, we didn't follow our order, we didn't follow our rules. And this is not just a Miss McNabb way of doing things. This is like the math order of doing things. So this isn't me just being obnoxious and annoying about how we get this stuff done and wanting you to do it my way. It really is, you're going to get it wrong if you just decide to add the 1, because you're going to add the 1 out over here. You can't just add it inside the parentheses because then you got the 1/4 that's being multiplied. You're messing with the order. It's very confusing. We're not going to add the 1 to both sides yet. We will eventually. So the first thing I can do, though, is I can distribute. So I can distribute. Remember that 1/4 outside of the parentheses means multiplication. So I can distribute my 1/4 to the x and the negative 12. I know that I'm still going to have y minus 1 equals. Now, when I have 1/4 times x, it is the exact same as if I had 3 times x. I can just write 1/4 and an x right next to it. Because when we have a number, even a fraction, right next to a letter, it just means it's being multiplied. So don't panic. That's super easy. This gets a little trickier. You need to use Desmos to find the answer for the negative 12 or the 1/4 times negative 12. The answer is -3. If you need help using Desmos, go ahead and let me know, and I would be glad to help you out with that. So we do know that 1/4 times -12 is -3. So we have distributed. I'm going to go ahead and check for like terms. I can't combine my y minus 1, and I can't combine my 1/4 x minus 3. so we're good. Can't do any of that. Moving right along. Now I need to add or subtract across the equal sign. That means moving stuff across to try to get my y by itself. Now we can add our 1 to both sides. I know you've been waiting for it. It just looks so easy right there at the beginning, doesn't it? But it's tricky. You can't. Okay, Miss McNabb. Here we are. And then plus 1. Remember, if I do something to one side of my equation, I have to do it to the other. It has to stay balanced. If my sister gets a cookie, I get a cookie. Can't be handing out random cookies whenever we feel like it. Got to be fair. Okay, so 1/4 x. So y equals 1/4 x. And I know, again, by using my Desmos calculator, that -3 plus 1 is -2. Okay, I've got this in a y equals form. I've got it into y equals. I've solved for y. I have an mx. My m is going to be 1/4. I have x. And then my b value is going to be -2. So I am Dunskies. Okay. Now we are going to go ahead. I'll give you guys a couple seconds to go ahead and screenshot or try to work or copy your own. Okay, moving along. Number 3. Last but not least, this one gets a little tricky. Okay, so remember when we do this one, we are going to continue to use our, we're going to use our distribute, combine like terms, add or subtract. This pattern, if we get used to it, guys, will really help us, because we saw in the last one that a lot of us, when we were in class, a lot of us wanted to just add that 1 to both sides on the last problem, and it just does not work. And I can see why it's tempting, because it looks super easy, right? And you're like, yes, I got this, but it's not. So that's why we have this pattern here, this diagram down here, to help us remember. We distribute, we combine like terms, we add or subtract, and then we multiply or divide. And then for the ones up at the top, we do not cross the equal sign, and then the ones at the bottom, we must cross the equal sign. So here we go. Let's look at this. This one gets a little tricky, but I think we can do it. So we do have parentheses, and we have something outside of parentheses here. But it's a little tricky because we have a negative sign. Now, I want us to think about, what if that negative sign wasn't there? What is being multiplied here? Remember, there's an invisible coefficient always. So if I just have the letter x, it really means I have 1 times x. And I know that because I know that 1 times 2 is 2. I know that 1 times 7 is 7. I know that 1 times 196 is 196. I know that 1 times algebra is algebra. And I also know that 1 times x is x. So I can imagine that there's a 1 out here actually right in front of that. And then we also have a negative that the equation gave us. So there's actually an invisible 1 right there. So I know that my number that I'm going to distribute is going to be -1. That's what I'm distributing to everything. Okay, it's -1. So don't let that trip you up. When you see just a negative sign, just be like, I got you. I know you got that secret 1 that you're hiding. We got it. Okay, so now we don't change anything on our left side of the equation. So we've got y plus 2 equals, so -1 times x is going to be -x. And then -1 times 7 is going to be -7, because a negative times a positive is always a negative. Okay, see, that wasn't too bad. I just have to know that there's always that sneaky little one hanging out there. So I have distributed. Let's check for combining like terms. I cannot combine y plus 2, and I cannot combine -x minus 7. Okay. Next step, I need to add or subtract to try to isolate or quarantine my y. So I know I can subtract 2, remember, inverse equation or inverse operations. But if I do it to one side, I have to do it to the other. -7 and -2 are like terms, so that's why I write the -2 under that, so it looks like a pretty little math problem. Fascinating, it's like we're in math. Oh, Miss McNabb, it's time to change colors. Okay, so we have y plus 2. We know that 2 minus 2 is y equals -x minus 9. Because I know that using my Desmos calculator, I know that -7 minus 2 is -9. I've got it in my correct pattern. I've got y equals, got it. I got a x times something. Remember, I'm smart, so I know that there's that invisible 1 right there. But so it's -1 times x. So -x, I can write it like that. And then I know that my b value is -9. So we have our final answer. So I hope you found something helpful in this. If not, feel free to email me and I'd be glad to work through some more with you. Remember, this links up with your 7.3 notes on moving from point slope form to slope intercept form. And we like to do that because it's a lot easier to look at this and graph it than it is to look at this guy and try to graph it. It's very confusing. So thank you so much.